Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the 2008 Calculus BC exam, question number 6, from the non-calculator portion. It is a pretty involved differential equation with a little bit of logistic growth involved. The question reads, consider the logistic differential equation dy over dt equals y over 8, parentheses 6 minus y. Let y equals f of t be the particular solution to the differential equation, with f of 0 being 8. A slope field for this differential equation is given below. Sketch the possible solution curves that go through the points 3, 2, and 0, 8. So if I was to do both, because they want both of them, the one that goes through 3, 2 is pretty straightforward. It kind of follows this wave here, and it goes asymptotic right around 6, which is presumably the carrying capacity of this curve here. And then it looks like it's going to kind of head down this way. The one that goes through 0, 8 is above carrying capacity. So actually, I'm going to switch colors for that one. Since it's above carrying capacity, we will start from above here, and it will arc down and head towards the carrying capacity. So pretty straightforward. Part A right there. Part B, it says using Euler's method, starting at t equals 0, use 2 steps of equal size to approximate f of 1. So when it comes to Euler's method, I always make a table. So I got x, y, I've got dy over dx, and then I've got new y. So as always, I like to review how to find new y. New y is going to be equal to dy over dx times the change in the x plus the old y. And that's an equal sign right there. Since we're going to be doing 2 steps of equal size, I'm starting at 0 going to 1. It'll go 0, 0.5, and then 1. So since they give us the initial condition 0, 8, the 8 goes in for y. Dy dx is what happens when I plug 8 into the differential equation. What I get is I end up getting a negative 2 when I plug 8 in for all of those y's into the diff EQ. The new y is going to be negative 2, which is dy dx. Delta x is going to be 0.5 or 1/2, and then plus old y is going to be 8. That results in the number 7 happening. So that is our new y. So 0.5, 7 is going to be our new y. Dy dx happens when I plug 7 into the dy over dt. So that means after I plug all that stuff in, I end up getting negative 7/8. And if you want to go ahead and pause and find out on your own how I got that answer, you're just plugging in the y value of 7 into the y values of dy dt. So then from here, negative 7/8, which is dy dx, or in this case dy dt, times 0.5 plus old y, which is going to be plus 7. And then that ends up getting you a number which ends up becoming f of 1. So f of 1, we can conclude then that f of 1, and if you want, you can go ahead and leave it unsimplified. Remember, the AP exam, they don't require you to simplify anything, but if you wanted to simplify it, you would get 105 over 16. Okay, that is B. Let's go and move on to C. Part C says write a second degree Taylor polynomial to approximate f of 1. So in this FRQ here, they're asking us to approximate f of 1 2 different ways. One using Euler's method, one using a Taylor polynomial. So it's just multiple ways of getting a similar answer. So when it comes to a Taylor polynomial centered at 0, it's really a Maclaurin polynomial, but they just didn't want to type it out that way. It's no big deal. We can say then that f of t would be equal to f of 0 plus f prime of 0 times x plus f double prime of 0 x squared over 2 factorial. Now I just have to find out what each of these values are. So from here, f of 0, we already know that. We know that that's 8. They told us that. F prime of 0 is actually negative 2. How do I know? It's because in the Euler's method portion of the problem, we actually found out that answer. Dy dx at 0, 8 was actually negative 2. So we can go ahead and borrow from part B to say minus 2x. And then plus it's going to be some kind of x squared over 2 factorial, but I don't know f double prime. So that is actually where the work kind of comes in. I better find out the second derivative of this thing. Well, remember, dy over dt is equal to y over 8 times 6 minus y. In order to find the second derivative of that, I'm going to do d over dt to both sides. So what I get is I get d squared y over dt squared is equal to, this is going to require product rule. So what I get is I'm going to go first unchanged, so that's going to be y over 8, and then the derivative of the second is going to be negative dy over dt. And then plus second unchanged is going to be 6 minus y, and then the derivative of the first is going to be 1/8 dy over dt. That's our second derivative anywhere, but we don't want the second derivative anywhere. They want the second derivative at t equals 0. But remember, our second derivative, or even our first derivative, is not in terms of t, which is why we need to kind of readjust this. The idea of at t equaling 0, another way of looking at that is y being 8. Again, how do I know that? It's because they gave me the initial condition, f of 0 equals 8. So from here, what's that going to look like? Well, that's going to look like 8 over 8 times. Now remember, dy over dt at 0, 8 was negative 2. But he's still being negativized, so I know he's going to end up being positive at some point. And it's going to be plus 6 minus 8 times 1/8, and then negative 2 here. So for purposes of this, I think I am going to simplify this thing. So I end up getting this to become 1, this will become 2, and then this guy here, looks like I get a negative 2 here, times negative 2/8. So negative 2/8. So that looks like it's going to become plus 1/2. And if I was to add those up, it would become 5 over 2. So the 5 over 2 jumps down here, and I can go ahead and leave him like this, if I wanted to. If I wanted to simplify it, I could actually simplify and make this 5 over 4. In fact, I'll write it down here. 8 minus 2x plus 5/4 x squared. Alright, now let's go ahead and use this to approximate f of 1. Well, f of 1 will be 8 minus 2 times 1 plus 5/4 times 1 squared. Now again, you can leave it like this if you wanted to. The AP exam won't require you to simplify. But if you did want to simplify, you just get a common denominator all the way around, getting you 29 over 4. Part D, it says, what is the range of f for t being greater than or equal to 0? Well, remember, our f of t at this point in time is 8 minus 2x, or rather 2t, I should call it 2t, 2t plus 5 over 4 t squared. Now, if I look at f of 0 for a second, that gives me 8. And why is that important? That tells me which curve we're talking about. We're talking about the top curve here, because the top curve has a y-intercept of 0, 8. So if I'm looking at the range, it looks like it's going to go, as it starts at 0 and gets larger, our end is going to be 8. And as we move towards infinity, this thing will bottom out at 6, but we'll never get there. So that's our range. Alright, and I think that will wrap it up for this video, as well as this series of FRQs. As always, please leave questions and comments in the comments area, and I will see you in the next one.